Hello everyone, NadLabs here, and today I'm just going to be doing a very simple beginner's guide to Godot. The first part, which is going to be over here in the YouTube timeline, which is just it's just going to be a beginner's intro guide to like just basic concepts in programming, like what's a variable, stuff like that. And then over here, somewhere in the middle onwards, is going to be an actual game, and I'll just show you what the game looks like. So we'll just be making a simple game like this, where you will be the blue Godot image, you'll be icon.png, and you just have to be moving around. As you can see, some enemies disappear after a while, different enemies spawn from different locations, stuff like that, and that's the game we're going to be making. So if this is something you want to watch, then stick around. If you really want to get started with GDScript or Godot, you obviously have to make a scene. So I'm actually going to just close this one, not delete it, and I'm just going to click new scene. I'm going to call it my scene. You have to save it. So I have my scenes over here. I'm going to attach a script by clicking this green plus icon. I'm going to create it. Of course, I get this boilerplate text. I don't need it. I'm going to show you what you would most likely be using on a day-to-day basis if you're using Godot. For example, if you're making a really large game, this is basically what you're going to be using. I'm trying my best to make sure that this tutorial will help you understand. And usually I find when I'm watching beginner tutorials in any language, they usually get really hyped up with defining variables, and you don't need that many. In fact, you just need the string. This is how you make a string, which is just a sentence. This is how you define an integer, which is just a number from like 1, 2, 3, 4. It cannot be a decimal. That's what floats are for. And over here you have an array, and this is basically it. And I don't know anyone who uses constants in their project. I mean, I've used it like maybe once, and that was because I was feeling like I could use a constant here, but usually I use variables. I know it's bad practice, but hey, if you're trying to learn, the best way to learn is just to go fast and not get stuck up on all the little details. There is over here, you can see I put a colon, and you can do this, and it essentially allows you to define the type. So you can see over here that this is a type of float, and Godot doesn't yell at me. But if I say this is a type of string, Godot will get extremely mad at me in just a second, saying the assigned expression type doesn't match the variable type. And I guess another thing about learning Godot is learn to read the error messages. I mean, they are sometimes a little bit hard to understand, but usually if you read them word for word, and that's something I wish I knew when I started out Godot, if you read the error messages word for word, it will tell you what you need to know. And if you're having trouble understanding this, you could literally just Google that, and within the first few results, just open up the first few ones, and you'll be getting a couple of web pages where you can go and learn. I mean, Google's your best friend, or if you want to use DuckDuckGo or whatever, same idea. Oh yeah, and I also forgot there's also the vector variable, and you can just pass in an x and a y. As you can see, Godot will actually tell me it wants an x and a y, so I can just pass in any x and y. And this basically allows the vector2 to be pointing towards 5, 5. What that essentially means is if this was my like graph paper, it would be going 5 to the right and 5 to the left. As you can see, this is not to scale, and it would probably be pointing over there. If you don't understand what any of this means, I would highly recommend watching some vector math tutorials. And if you want to know where to find vector math tutorials, you can literally just search up vector math tutorial, not tutor, but tutorial. And if you just scroll down and look for Khan Academy videos or the Coding Train videos or TED, like all of this stuff is on the internet, and you can figure it out. I don't want to say that to be rude, but I want to say that because one of the biggest things about learning GDScript or any program language for that matter is learning to ask the right questions, because I feel like that's a more important skill for a programmer to have, to be able to ask the right questions and being able to figure out what needs to be Googled or what needs to be asked in order to get the project done. Then we have the ready function. This only happens once at the beginning of the scene. If you don't know how I found that out, you can just control click it and it will tell you calls when the node is ready, and it only fires once because you can only be ready once. I mean, once you're ready, you're ready. So you can't be ready once you're already ready. Over here, you can see in the documentation that the ready function just is called once or is used once when the object enters the scene tree or enters the tree or enters the game scene. Then we have the physics process function, and I'm just gonna move up a little bit because there's actually something alongside the physics process function, and that's the process function. And you might be wondering, what's the difference between these? Well, the process function will happen every frame, and sometimes it'll happen faster than a frame. And you might be wondering, what does that mean? It might happen 2, 3 times a frame, or maybe it might not complete in a certain frame because the game might be lagging out really hard, and maybe the game's running at 2 FPS. The process function will only run, it might not even complete because the process function doesn't get a full frame to run. Whereas the physics process function will make sure to run once every frame. It will always happen at the same rate the game FPS is happening, usually, and the process function will happen at a rate at which it wants to, kind of independent of the FPS, but usually 99% of the time, if your game isn't lagging out because of some poor like code or because it's not really heavy on graphics, then this will be happening a lot faster than this physics process function. Then I wish I really knew when I was starting out with GDScript and Godot was how to make my own function. You can literally make your own function by typing in function, some whatever you want to call it. You should use the type systems in Godot, which is basically me telling Godot that this function will return nothing. If I wanted to tell Godot this function will return an integer, it will tell me that, hey, you're not returning anything. So I'm going to go over here to the bottom and say return, not run, but return, I don't know, 5 or 3 or something. And you'll see that Godot will say, yeah, that's an int. But if I say 3.0, this should throw an error and it should say you're not matching a float. And I can fix that by typing float over here. Anyway, then there's only really two things I could see a beginner using, which is if and a loop. If compares stuff, and if this expression doesn't evaluate to true, it'll go to this one, and if this doesn't evaluate to true, it will go to this one. And you can have multiple else ifs, by the way. You don't need just one. You can have multiple else ifs, but you should always have one if, one else. And then you have a loop. I found it really hard for beginners to understand what a loop is used for if it's not used in a practical setting. So we're going to be going over a quick example of how to use that. So this is basically how you construct it. So for R is basically an array, and it will go over this array by printing out, and we will actually be running this. It will be printing out each element one by one. So think of an array as a list, passing something into a function, and you can see over here I'm passing in something, and something is given a type of string. If you don't want to use types, you could just leave it like this. I mean, that to me looks a lot more bare. I prefer to have all the type and extra text over here because it tells me what I'm doing, and it actually tells Godot what's happening. As you can see, if I remove this, Godot gets rid of this green number, and the green number actually represents that Godot knows that this line will not fail, or it has a very low chance of failing. If I put this back in, you can see that Godot knows it's a string, and you can add strings together. And if you're wondering how I figured out I could add strings together, well, I actually learned how to add strings, or the reason I know that I can add a string to something else is because I can just Google that and I can say, can I add strings together? And you can see that you'll be getting a lot of stuff. But if you just search up the general question, Google will give you a really short description and say yes. And in most programming language, including GDScript, Python, basically any programming language, or most of them, you can add strings together. In fact, I'm not aware of any exceptions to this rule. But all of this is pretty much useless, and that's the reason I was really hesitant to make a GDScript basics tutorial, because this doesn't mean anything to anyone because there's no practicality surrounding it. So I'm going to be going over really quickly how you can make a very simple game in Godot. To make the game that you saw at the beginning of the video, we're just going to make a new project. I'm just going to call it a simple game. I don't know, just something simple. So once I got the project created, you see I'm put into the 3D view. I'm not sure why. If you want to go into the 2D view, you can just click up here. Or if you want, I don't know why they changed it in Godot 3.3, but over here in the editor settings, it used to be that in the shortcuts, you could go to 2D view. You can go open the 2D editor by clicking. The new one is Control F1, but I personally like F1 because that's what it was before. I don't know why they changed it. Anyway, so over here we have our scene tree. Over here we have our little file system, and over here we have properties for our scene tree. And I'll just show you what this tab on the right, or this window on the right does. Basically, if I click something over here, you can see this changed, and I get a bunch of properties. 99% of the time, you will not be touching material. You might touch visibility, you might touch z-index, but you'll mainly be touching transform. And transform is just it just contains the position, as you can see, rotation and scale. What does that mean? So let's add a new node. So how do I add a new node? I would go over here to this plus icon, or I can click Control A, really handy shortcut. So I'm gonna add in. So first of all, I'm gonna add in a sprite, and a sprite is just an image. It just means image, really. And you can see I can now drag around this Godot icon. And how did I do that? Well, I clicked W. And how did I figure out to click W? Well, over here you can see I had the cursor selected, which was right now, which is what I have selected right now. But over here I have the move tool selected, and that's W. And don't worry, you'll get used to the shortcuts over time, and you can see that it's just the top row of keys for this main section over here. So I can now rotate after selecting it, rotate the sprite, and you can see over here if I go to the transform, you can see that the rotation changes with it. I can click W and move it around. As you can see, the position changes as I move the sprite, and that's basically all you really need to do. Oh yeah, and modulate, which is my favorite. It just lets you change the color of the sprite. So if you have a white tile or a white image, then you can literally just make any color you want, which is really handy, and it's something I really like about Godot. Usually in tutorials, people go around and talk about every single thing, every other tab, but I'm not going to do that because it's just better to start with the basics. So now I'm going to get rid of the sprite because I want to actually make the game. So I'm going to go over here, delete this node. You can just do that by clicking delete. So I click the delete key, or you can right click and delete node and get rid of it. I usually like to name the scene where all the game stuff is going to be happening, the main game screen, I guess you could say. I just like to name it game scene. So now I'm going to Control S to save, or you can go up here and save, but I don't know who does that. So I'm just going to click right click new folder. Usually a lot of people put their code stuff and their scenes in a source file, and all their assets, which there will be none for this video, into a assets files, and you can make an assets file like this, and you can basically put anything you want, but I usually make my tutorials without that because you just need the icon.png really. So now we're going to go over there and make a player. As you can see, I went over here to make a new scene, and a scene is a core concept. Think of it as a Lego brick. I can put these Lego bricks, these new scenes that I make, and I can put these Lego bricks or new scenes and nodes into my game scene to make a beautiful Lego creation. So what does that mean? Well, if I head over to Paint, if this is my game scene over here, not in black but in red, and if I have a player, well, my player is going to be a node or a scene on top of the game scene, which is in red. And then if I have a bunch of enemies, I can just stack the enemies on top, and I can keep on making enemies. And they'll just keep on spawning, and this is all on top of the game scene, and this is my new Lego structure. So this analogy might become more apparent later on, or it might be a waste of time, who knows. So over here, I'm going to go over to my new scene, just going like that, new scene. I'm going to make I'm going to add in a new kinematic body 2D. What's a kinematic body 2D? Well, if you don't know, just right click, open documentation. You can see I'm in the kinematic body 2D documentation, and it basically says this is something that you can move around. It's like a character, and it basically allows you to move stuff around. And there's two main things that they really highlight: move and collide, move and slide. Usually you'd use move and slide. That's what we're going to be using. And after you read this big block of text, up to you if you want to, you can see that move and slide just moves the player along a vector. So this is the first keyword I want to highlight, vector. If you're not familiar with what a vector is, I highly recommend checking some resources I'll leave in the description to watch before continuing or whatever, because understanding what a vector is really important. But just to give you the quick rundown, a vector is essentially just a line. So if this is a 2D plane, this is just a line pointing out, and it has a specific direction. So now moving back to the kinematic body 2D or the actual scene tree, we can just click over here to our 2D viewport, and we can go back, and you can see that this player is empty. Actually, you know what? Speaking of player, we should actually name it player. So I just double click to rename it, and I'm going to Control S to save the scene. Now I'm going to go over here to my source, and I'm going to make a new folder because I like to keep my stuff tidy. I'm going to make a player folder. I'm going to say player scene.save into the player folder, and as you can see, underneath the player folder, I have my player. Now I'm going to go over here, and I'm going to see what Godot is yelling at me for, and it says it's yelling at me because there's no collision shape 2D. Okay, so I'm just going to go over here to my add scene, collision shape 2D, and I have something over here. Now Godot's yelling at me again, and it says you must provide a shape. Okay, so over here I see there's something called shape, and I'm going to click it, and oh, okay, rectangle shape 2D, and down there's a little rectangle. So let's see what happens if I add this to my game scene. And this is the analogy of the Lego bricks I wanted to talk about. As you can see, now I'm going to add my player to the scene, and now I have a player. And it's like adding in a Lego brick where I can now build stuff on top of that. So I'm going to go back to my player, and I'm going to show you what happens if I make a change over here. So let's say I add a sprite, and I'm going to add in an icon.png so I can actually see my player when the game runs. I'm going to make it a little bit smaller. Maybe about that big, and you can see the collision shape disappeared, but that's because Godot renders stuff from top to bottom in the scene tree. So over here we have the player, then the collision shape, then the sprite. If I bring this down, you can see that the order changes, and now the collision shape is on top. Let me just change the modulation so you can see it a bit, and as you can see, the collision shape is on top of the sprite, and it actually goes above it, and we can see it now. So if I go over there to my new game scene, and as you can see, everything's updated and everything's ready to go. If I want to run the scene for some reason, I can just click F5 or this play icon, or any one of these honestly, and really just any one of these, and you can see that my player shows up. But I want to move this player around, so how can I do that? Well, I can go over here to my player and I can click add a script, or attach a new script to, or an existing script if you want. And I'm just going to click yes, and I'm just going to accept everything as default. I already have the player script, but I'm just going to go over these details. So language, you can choose the language. If you have the mono or the C# version of Godot installed, you can choose C#. I might do a tutorial about that later. You can see over here we have inherents. This is basically for making let me just change the file name so it doesn't think I want to load one. So over here you can see inherents. I can basically tell this to inherent from another script if I really wanted to. That's a different tutorial altogether. Class name, that's a different thing. Don't worry about these two if you're just starting out with Godot. Template, it just means, do you want to have these comments in the background? As you can see, we have some comments over here. I'm not sure how visible that is. Or we can just have empty or whatnot. Anyway, so we have this script over here, and Godot tells us a couple things when we look at it. And I just went into distraction-free mode, by the way. So I just clicked this full screen icon. So over here in our kinematic body 2D script, we have extends kinematic body 2D. Don't worry about this. Usually you don't have to touch this, but this basically means, or this tells Godot that this script will be using the kinematic body 2D API. If you don't know what that means, don't worry, because that's not important for the beginning of Godot. It just allows us to have access to all of these special functions, which are basically superpowers. Anyway, from the beginning of the video, we learned how to declare variables. So we're going to declare a couple of variables. So we're going to declare a variable called speed, because that would be a good thing to declare. And I want the speed to be 400. You can set this to whatever you want, but after using Godot for about a year, at this point, I think 400 is a pretty good speed. It basically, you can think of it as pixels per second. So now, what should we say? We should tell our player to spawn in the center of the screen. So I want to get a variable to our screen size, and I know this will be a vector 2 because the screen is actually a vector 2 itself, or at least the screen size is a vector 2, and it actually just is a line pointing from up here in the top left all the way to the bottom right. And you can see that I should not have let go of the mouse, but over here you can see that this blue line that I'm dragging around, that's kind of like a vector 2, and this is what the screen size will be giving us. And the components of that vector are going to be, if you can see at the bottom, I can't really show with my mouse, but I might put some arrow or some text over here to highlight the size of the screen. So it's around 1024 by 600 pixels. And those are going to be the components of the vector we want to get. But I don't want to hard code that. I want to get it through Godot itself. So I'm just going to go over here, load the script that I accidentally got rid of, and I'm going to go over here and I'm going to get a ready function, because you can't get the value up here. As you can see, I'm not setting the value to anything. You usually have to get the screen size when the game is ready, and you can see that by typing pass, Godot stopped yelling at me, and you can see that it expects something to be after this this indentation, but there's nothing. So I can just tell Godot to pass so it stops screaming. Just think of pass as something that Godot doesn't mind, and it'll stop yelling at you for. So over here we have screen size, so we can actually set the value of screen size to, and this is going to look very confusing for beginners, but this is some like inbuilt function. You can't really think of this yourself, unfortunately, because this is just a function built into Godot. As you can see, I go to the documentation by right-clicking and control right-clicking it, control left-clicking it. And I can go over here to the documentation, and it returns. So returns is a really important word, because this is what the function will give you. It gives me a viewport boundary as a rectangle 2. What's a rectangle 2? Well, a rectangle 2 is a box, and this box has a couple properties, which are its position, size, and end. If you don't know what a property is, it's basically like a detail. It has details of its position. Where is this rectangle? How big is this rectangle? Where does it end? And you can see the size of the rectangle is what I'm getting, right? Because this is a rectangle 2, and I'm getting the size. Dot size is how you can access properties. You can access other properties. There's a lot of properties, and some are methods and whatnot. But I want to see, you can see that end of properties over here, and there should be a position. Yeah, there's a position property, but I want to get the size property. And now I can say at the ready function, as soon as this game starts, I want to get my players. What do I want to get of my players? I want to get my position. but not any old position. I want to get the global position. The reason you want to get the global position of the player, I mean, you could get the regular position too, but generally it's just better to keep everything in global coordinates, because up here in the game scene, right here is 0, 0, and everything else starts to expand. As you can see, right here is 1000. Right here is 1000. Over here is like negative, what is that? Negative 100, and up here is like negative 100. Down here is like 800. So you just want to keep everything in global coordinate system, because if you keep stuff in local coordinate system, then what happens is Godot might think, actually it works better over here. Godot will think that this sprite is actually 100 pixels away. But when I go over here and I save the scene here, you can see that the sprite is actually, it might seem like the sprite is still 100 pixels away. But if I ask for the global position of the sprite, then I'll get something a little bit different. And it's just a really complicated mess. Just keep stuff in global coordinates, and you can do that by doing global position equals, or dot global position, whatever, what have you. So we're going to be setting the global position of our player. If that's not clear how we're setting the global position of our player, it's because this script is on this node. This script will affect this node, which means we will be able to modify this position value in code. If you're wondering how I was able to change those values, if you just press into it and move your mouse, you can basically change the value. It's a really handy feature. Anyway, we're going to go back to our script, and we're going to be saying the same thing, but in a different way. So we're going to say self.global position equals, and that's the exact same thing as saying global position. It's the exact same thing, but there's no need to put self. It's redundant, really. So we're just going to be telling our global position, which, if you don't know, by the way, you can control right click. Global position is going to be a vector2. Right over here on the left of the property, it will tell you the type. So if you go over here, global position is a type of vector2. That's just the fundamental label we give it. Like the idea is just a vector2. That's all you have to know. And a vector2 is just a position. It's just like a place in space. So we're just going to tell this global position to be screen size divided by 2, really, because we want to get half the screen size. And now when I run the scene, if I click F5, click the project settings, take this as my main scene that I want to run all the time, you can see that the player's in the center, even though over here, if I move it up into the top right, when I run the scene, it will still be in the center. That's because we're setting it at the beginning with code. And if I can comment that line out by clicking Control K, you can see my code doesn't affect the player. So now we're going to be getting the input movements. So how can we get the input? Well, I said last time that we could use the input function, but it's better to handle really fast input, like player input, through the physics process function, because we want to check that every frame. So how could we do that? Well, we could make a variable called velocity, give it the type of a vector2, set it equal to, I don't know, like let's just make a quick function over here, times speed. So what's this function? Does Godot have it? Nope. We have to make it ourselves. We can make a function by ourselves by typing in function. Let me just go into distraction free mode. Function, get direction. I'm going to make it return a vector2. And I'm just going to be saying, I'm going to be making a variable called direction here. I'm going to give it a type of vector2, and I'm going to return this direction. I'm going to just return direction as well, because I want to tell Godot that this type of function is returning something. I'm going to tell direction that direction.x. So I'm going to be accessing a property. As you can see, I'm going to be accessing the x property, which is the x component, which means the horizontal component, not the vertical one, but the horizontal one. This is x, this is y. At least in in like coordinate systems and games and stuff, x is horizontal, y is vertical, and basically I'm going to be saying that direction.x is equal to, and this is going to look scary for beginners, but mind you, this is one of the few things that will look scary. This is like the hardest. Get action strength UI right, and minus input dot get action strength UI left. This is the hardest part. Like these are the hardest lines for a beginner to understand, because this looks so alien. But the reason it looks alien is because this is something really hard coded into Godot. And before I recorded this tutorial, I was wondering what I was going to say about this, and I realized that most of the input stuff in Godot is hard coded by default, because if you think about how inputs work, or inputs are like stuff you type into a computer, that stuff is hard coded into like the BIOS, because, or the basic system of the computer, because to understand what a Y is, everyone has to agree that the letter Y is going to be a certain key code. And if you go over here to a key code, you can see that Godot actually has certain keys for each letter on the keyboard, and this stuff is hard coded. Like the letter L is 76. Like this stuff is hard coded, and this is the reason why this looks a little bit weird, is because this stuff is hard coded. And what do I mean by hard coded? I mean, like it's not something like screen size where we can just like get this property no matter what it is. We have to be very specific with what we say. And you can see over here UI right. Well, that's actually, if we go to our project settings, we can go to input map, we can scroll down a bit, and we can see over here we have something called UI left. This is pre-built into Godot, and basically it allows us to get inputs from whatever UI left is allowing. And that right now is the left arrow key. So the left arrow key, and oops, I didn't mean to press it, but the left arrow key and a device 0 button 14 D-pad left. This is just for controllers. We can also add our own by going over here. I want A to be left. I want D to be right. W to be up. Oops, W to be up. And be careful, you can't click enter, because if you click enter, that actually considers it a key press itself. And S for down, sorry. And now you can see that so what does this actual sentence evaluate to, or this part of the sentence, or this part of the line? Well, basically when we get something like this, we're basically asking the input, whatever the input object is, we're going to be calling this function get action strength. What's get action strength? Well, it returns a value between 0 and 1 if we are pressing a certain key. The reason I like to use get action strength is because it allows for joypads to do something like 0.5 if you're doing like a half move kind of. For controllers, it doesn't make sense for keyboards because you can't half press a key, but this is just to like keep your code or game usable for other, if you ever want to expand it to controllers. So the reason we're doing right minus left is because in game engines, usually the right direction is positive. So we want to make sure if we're going right, or whenever we click the right arrow key, it's a positive direction. And if we're going left, it is a negative direction. That's why we have to do right minus left. Because if you're not pressing right, and you might want to pause, if this is not being pressed, what does it return? You can just read over here. It's returning 0 because nothing's happening. So 0 minus 1 is -1, and we move left. And same as the case over here. The reason we have to do down minus up, you might be thinking up is positive, but no. In game engines, usually down is positive, and then up is negative. That's just how it works in game engines. It has to do stuff with OpenGL and GLES, and it's just for easier for computers to think about down as positive, up as negative. And same as the case here. If I'm not pressing down, then this must be 0. So 0 minus 1 if I'm pressing up must be -1, and I'll move up. So now if I run the scene, you might think we get to move, but we don't, because I'm not doing anything with the velocity variable. Now if I go over here and do move and slide by velocity, everything should work. And I have a very simple movement system set up in Godot. Now, how do I set up the enemy? So I'm going to go over here to a new scene. I'm going to exit distraction free mode, make a new scene. I'm going to go over here, and I'm going to actually make my enemy an area 2D. The reason I want to make an area 2D is because I get access to these amazing signals, which basically say how I can detect stuff. So I'm just going to go over through the simple motions of giving it a collision shape, giving it a shape as well. If you're wondering why I did that, if I go back, you can see Godot tells me it doesn't have a collision shape. Should go add that, not that way, but this way. And now over here, you can see it's yelling at me for not having a collision shape. Now it has a collision shape, so it won't yell at me. Now I'm just going to add in a sprite because I want to be able to see this when I'm playing my game. And I'm just going to shrink it down, and I'm going to give it a red color for a red enemy. And I'm just going to do, and you can see that the collision shape, I accidentally did this. I was trying to move it down, but the collision shape over here it has a shape, but it's not the child of the area 2D. It's the child of the sprite. And this area 2D thinks the only child here is sprite. So it says, hey, you didn't put a collision shape. But in reality, I did. But it's not the child of the, it's not a child of the area 2D. It's a child of the sprite. Or it could be a child of anything. It will still cause an error. So just changing sizes of stuff. And over here, I'm going to make a new folder called enemy. And I'm going to click save, but I purposely did that because I want to show you that area2d.scene doesn't make sense. So you can actually rename your scene like this, in case you ever mess up, and just rename that as well, so everything makes sense. Usually you can name this whatever you want, and Godot won't change the file name because this is a file. The scene is a file. Like if I go over here, open in File Manager, you'll see that this is just a file that I can open up in Notepad, and you can see this is just like text. And if I went over here like this, come back, reload, you can see it's green because I changed the text file. But in reality, because this is just me changing the text. As you can see, if I save this and I click reload over here, it changes the stuff over here as well, because these scenes are just text files. So that's why this name up here does not reflect this name up here, because this is stuff I put into the actual text file. As you can see, this name matches this, but Godot doesn't care. It cares about what's over here in the tab or the file name. So that's just something to keep in mind, because that really confused me just a couple of days ago when I was working on a project. Anyway, so I'm going to attach a little script over here. And what do I want to say in my enemy script? Well, I want it to move around, so I'm going to give it a direction. I'm going to give it a direction up here because I want to do something special with it later on. And I'm going to basically be saying function in my physics process function. I'm just going to say global position plus equals direction. And this basically allows our enemy to move. So if I do, let's say I just set the type really quickly to vector 2.1, and this is a really good example. Vector 2.1 is actually just a vector 2.1. You can't see any of that, so let me just go like this. Vector 2.1 is actually it actually looks like this. So it just means that we have a vector 2, and it's going to be given the values of 1 and 1. If you know that right and downwards are positive and left and up are negative, which way do you think vector 1 is pointing? You might want to pause and think about it. So if this is my coordinate system, vector 2.1 is pointing in this direction. And I can prove that by running, not the game scene, but if I click F6, or if I click this little snapper icon or whatever it's called, or this display button over here inside of a movie icon or whatever it's called, you can see that I'm running and the enemy is moving in the same direction as what I drew over here. So that's how we're going to move the enemy. But what is direction? Where are we going to get it from? Well, I'm glad you might have asked. And basically, I don't want to get rid of that. I want to get rid of the value. Basically, in our game scene, we're going to be creating a timer, which is exactly what it sounds like. Not a timer, but a timer. And basically what we're going to be doing is we're going to be telling it to, we're going to be saying every time this timer times out, so we can just name it like the enemy spawn timer. We're going to be saying timer timeout. Every time this times out, we're going to be spawning an enemy. So hopefully we can just do this, spawn enemy. And will Godot understand this? The answer should be no, because spawn enemy is not something built into Godot. We have to build it ourselves. So we're just going to go over here, create a little function ourselves called spawn enemy, and you're going to see why we want to make it a function and not just type out the code over there. And what are we going to do in spawn enemy? Well, we're going to be saying variable enemy is, and this is how you instance a scene. So we're going to give it the type of area 2D, because that's our enemy type. As you can see up here, enemy type is a area 2D. This is an area 2D. As you can see, area 2D. We're basically going to say enemy type is going to be equal to a preloaded scene called enemy.scene.instance. We're going to be instancing it. That's why it's called instancing a scene. And let me just move this down because I know the YouTube bar comes up and whatnot. So enemy, we're going to be saying add child. First of all, we're going to add child enemy. What are we adding the child to? Well, if we go over here, we're going to be adding a child to our game scene. That's actually incorrect because I'm doing this on the player script. So be careful of the scripts you actually write your stuff on. So I should actually create a game scene script, and I should paste the code over here, and I should go disconnect my signal. That was a complete mistake, but that happens, and I'm glad it happened on camera to show you everyone what's up with learning. So you can see over here it didn't connect. Sometimes it's just a little bit buggy, but whatever. So in our game scene script, we should be spawning an enemy because we want to spawn an enemy up here in the game scene, not on the player. That wouldn't make sense. So now that we are instancing a enemy object, if you want to think about it, we're like creating a copy. Instance just means create a copy. You can see instance, where's instance? Instance instantiates the nodes hierarchy. That's still pretty complex. If you really want to figure it out, you can just Google or DuckDuckGo instantiate, and it says to represent an abstract copy. Again, it's pretty complex. It just means to make a copy of. I don't know why they didn't say that. Anyway, so we go over here to our game scene. We're going to be adding a child enemy, and now when we run the scene, nothing happens because we did not tell our timer to auto start. Auto start, as the name suggests, if you wait for a second, you can actually get a little description of what it is. Auto start means the timer will start when the game starts. If you don't want to click that, you can basically make a ready function, and you can say you can get the node itself. So you can do enemy spawn.timer. You can do enemy spawn timer.start, and it'll just do the exact same thing as auto start. And if you see this, we can see we get our enemy, but it's not moving. Why? Because we have to tell our enemy dot direction is going to be equal to, let's say we do vector2.1, right? And if we do this, you can see that every second we get, because the wait time is 1 second, by the way, every second we get an enemy spawn. Over here in the enemy spawn timer timeout function, which basically means every time this timer hits 1 second, we can also tell our timer by getting an instance to the node, or by getting access to the node by putting a $sign dot, we can tell the wait time to be equal to a random range. A random range is exactly what it sounds like, a random number between 0 and 1. So now we will get random enemy spawn times between the timer. As you can see that like the closeness is, I guess, a lower number. Farther away, it's higher wait time. Anyway, that's just a cool thing I like to add. I always love using random ranges. Gives the game a little bit more spice. Anyway, we can also say, so right now our enemies are spawning in the top left, which is kind of boring. If that's the game you're going for, I don't mind, but that's boring to me at least. So we're going to be trying to tell our enemy to move in the direction of the player. Well, we can do a little bit of vector math, and we can say get the player dot global position equal player dot global position minus our enemy dot global position. And if we do this, you can see that we're going to get some big weird stuff, which is our enemy just flashing in front of our face. Why? Because this vector is actually really large. Because the reason why the enemy just flashes in front of our face and runs away is because this vector is extremely large. Our player is over here, our enemies are spawning up here, and that is a really large vector once we subtract them. What we want to tell Godot is normalize the vector, which means make it a really small length, which means length 1. Normalizing a vector is just fancy talk for saying normalize the vector is just fancy talk for saying make it a length of 1. As you can see, if I go over here dot normalized and I go over here control right click, and you can see it returns the vector scale to a unit length. Unit length is length 1. It gives you the formula, which is just taking the vector itself and dividing it by its length. That's just fancy vector math. All you have to know is this how you can make a vector small. And basically now when we run the scene, we're going to be getting our enemy moving in a direction. And as you can see, it doesn't affect the previous enemy. It only affects the current enemy that's being spawned, which is, I guess, what if you're going for. But if you want it to be different, then if you want the enemy to follow the player, what you can do is you can take this exact line of code and you can actually paste it into here. And now you can see we get an error because player isn't defined. If you want to define a player, just a quick sidetrack, you can go into the ready function, create a player variable, give it a type of kinematic body 2D, because that's what the player is, right? It's a kinematic body 2D, as you can see up here, kinematic body 2D. Just to show you, if I open the documentation for it, it's a kinematic body 2D. What we can say is we can actually go over here and we can say player is going to be equal to, and we're actually traversing the game scene right now. So if I just go over here, click this enemy script, our enemy basically essentially spawns like this. It spawns over here in the scene tree because we're saying add child, add the enemy as a child over here, and this is what this spawn enemy function does. So our enemy is in the game scene, just vibing, and it says at the ready function player variable is going to equal get parent. So we're telling our enemy to get its parent, go up a level in the scene tree and get the node called player. And now I can get rid of this, and now when I run the scene, our enemy should always be moving towards the player. But it's not, because it wants to get access to itself, not the enemy.global position. And now you can see the enemies will always be moving towards the player. Now you might be saying, NadLabs, that's horribly slow. Well, you can add in a speed variable, give it a type of, 3, because you don't want to do a big number for area 2Ds. Just keep that in mind. You might want to do a bigger number for kinematic body 2Ds, but not for area 2Ds. That's not a good idea. So now you can see we have our enemies following us all the time, but I don't want that. I want my enemy to be following us once, and it'll just be moving in a direction once. I can also just multiply that by a speed, and now you can see now I have a simple little game where the enemies are spawning, but that doesn't look like what I showed you at the beginning of the video. That's because I wanted to show loops. So how can we get a loop to work? Well, we can basically say for I in I don't know, for 10, whatever's inside this block of code, whatever's inside here, and I can show you what here is. If whatever's inside here, so let me just do a couple of these. Whatever's inside this block of code, and this is a block of code. If I get rid of these pass functions, then the only part of this block is this spawn enemy. Whatever's inside this block of code will be done 10 times every time the timer times out. So what does that mean? Well, it doesn't look like anything because all the enemies are spawning over here. But let's say I tell my enemy, well, you know what? I want you to spawn in a random position. Now you can do the random like position spawning over here in the spawn enemy function. You could do it over here in the ready function of the enemy itself. But I like to do it over here in my actual enemy script because I want everything to be clean and organized. So again, we're going to be making a variable called a screen size because we want to get access to the screen size variable. It's a better idea to define the variable inside the screen size function because we only want to get it once. We can also get rid of our player stuff because we don't need it anymore. And we're basically going to be saying, like before, get viewport rect.size. And the reason I'm doing this is because I want to be able to figure out the screen size so I can set my enemy's position to be something, you know, I want the enemy position to be randomly produced, so it should be produced with reference to the screen size. So we're basically going to be saying global position dot x is going to be equal to a random range from 0 really to screen size, and because screen size is a vector 2, because get viewport rect dot size returns a vector 2, right? This is a vector 2, so we have access to the x property. We can basically say we're going to be getting and you can already see Godot is saying the passed argument type vector 2 does not match the function's expected type float, which basically means we have to do .x because .x is a float. .x is a, if I go over here, .x is a float. As you can see, it says the type is float. So I'm just piecing together little, it's like a puzzle almost, like coding is like a puzzle. You just have to piece together the right stuff to make sure everything works. And now you can see our enemies spawn randomly at the top. And this is a kind of a hard game. Okay, whatever. Now you can see our players are able to go out of the screen, and since this is a really simple tutorial, you can try learning how to set that up yourself. You'll fail at it most likely, but hey, if you only learn by failing, so that's a little exercise. That's an exercise left up to the reader. I hate it when my math textbook says it, but whatever. So over here you can see that there's no penalty for me touching the player, and you might notice one thing else. It might be getting a little bit laggy, and that's because if I go over here to my monitor, my FPS is still 60, but the amount of objects I'm spawning is going up increasingly fast, and that's because the enemies are not despawning. So I usually like to give my enemies or bullets or anything that is going on forever, I usually like to give it a timer, you know, like die timer. So after a certain amount of time, it will delete itself. And usually you can also use something called a visibility notifier, but I like to use a timer because it gives me a lot more control, because maybe I don't want to delete stuff as soon as it leaves the scene. Maybe I want to delete it after, 5 seconds. Maybe after 5 seconds, we should get rid of the enemy. So and I did this quickly, but basically I connected the timeout signal, making sure that the timer was going to auto start, give it a wait time of 5 seconds. So what does that mean in English? I made a timer that times out after 5 seconds. And after 5 seconds, we're just going to queue free the enemy, which if you don't know what that means, you can always just control click it. And it basically means that this node will be deleted, or it will be sent into the list of deleting, because the way Godot deletes stuff is a little bit weird. It sends it into a list of, it sends it into a list for being deleted. And then it says, okay, can this be deleted? Is everything okay for it to be deleted? And then it clears it from the memory and whatnot, which is something we don't have to worry about. But hey, so now you can see over here, if I go to my debugger, yeah, sure, my object is climbing, but after 5 seconds, as you can see, it goes down again because these enemies are disappearing. And as you can see, they're disappearing in front of my eyes. I don't want that to happen, so I can either increase the speed. Actually, I'll do 4 because 5 might be a bit too fast. And I can increase the wait time. So now, yeah, sure, there will be more enemies on the screen at a given time. But hey, at least the objects will be still be capped. Like before, I believe it was around 3,000. Now you can see after some time, you can see that it levels out. And it actually just stays around constant. And it stays around constant at 1,700 objects-ish, thereabouts. And you can see that we're spawning enemies. And they're touching us. And we should restart the game when they touch us. So how can we check if they touched us? Well, that's what we use the area 2D for. We can check if a body entered us. So this really confused me as a beginner. What's the difference between area entered and body entered? Well, kinematic body is a body. It literally says on the name, body 2D. How else? What else is a body? Well, anything that is a physics body. And you can see that this class physics body is inherited by a kinematic body 2D, rigid body 2D, static body 2D. You'll mainly be using kinematic and static bodies. Maybe you will use a rigid body, but hey, if it has a body in its name, you're going to be using the body entered signal. Don't worry about body shape entered, that doesn't matter. Just area entered, area exited, body entered, body exited, and I'm just going to double click, connect the signal up. As you can see, it gives me a little nice handy function. And if a body enters, and how do I know if this is in the player? How do I know if this body is a player? How do I know if it's not a rigid body or a static body? Well, I can go over here to my player, give it a group of player. So I'm just going to say player. You don't have to do this for such a simple game, but this really helps if you have a really big game, and I'll show an example later on. If body dot is in group player, and if you're wondering how I figured that out, well, literally when I was playing around with Godot and learning it myself, I would do body dot, and I would see, oh, okay, there's quite a lot of stuff I can do. How about like get what? What can I get? I can see get grooves. Okay, so I can set the player to something and I could check if it's in a group, but I found later on that there's something called is in, not is I on or is M, but is in. Like I can see if a condition is true, and that's essentially how I found it out. Like I was just playing around with Godot and I found stuff out. So if the body is in the group player, we can say get tree, right? And then if you don't know what functions you can use on get tree, you can go over here to get tree. You can click on the scene tree, and then you can see over here we have a list to a bunch of methods, and the method I want to use is let's see, is there anything that might resemble like restarting the scene? So you can just like give it a read through, and after giving it a quick read through, you can like see that hey, there's something called reload current scene. Like that's literally how I make some of my games. Like I see what functions are available and whatnot. So I see reload current scene, I click it and it says reloads the currently active scene, and hey, that's exactly what I want to do. I want to reload the current scene because the player was hit. The player has to restart. Now you can see that when I get hit, the scene restarts. As you can see that it just restarts. And if you're wondering why there's just a random player up or a random enemy up there in the top right, it's because this is actually the same enemy over here. The reason it gets moved around, and you might want to pause and think about it, why does the enemy get moved around? If I go over here to the script, that might be a little bit of a hint. That's because we set its global position to be something random each time we run the frame. And that's no fault of the owner of the enemy, but we just got to get rid of it because we don't want some random enemy being at the top. So how do we get the enemy to spawn randomly on the sides and stuff, like I saw at the beginning of the video, kind of like over here? And this is just the example project I made because I also need to learn from it. Like I also need my example open. But how do I get something like this? Well, we should think from first principles, and we should try to think of it like, how do we get the enemy to spawn on a random side? So okay, so we can break this problem down, and this is like the final part of the tutorial, which is breaking problems down. So let's say we have our screen. Okay. We want to try to figure out, and you might notice I've been saying we want to say, or we want to try, like this is how I think of programming, and I think it's a good way for a beginner to think about it, that you're trying to tell the computer something. How do we tell the computer that we want to spawn an enemy either up here or at the bottom, like somewhere on the top or bottom, and somewhere on the left and right? We want it to pick a random one, or we want to pick a random direction out of these four, but we can easily break it down into the X directions and the Y directions. So we can do a random function, so not rand range, but like we could say if a random float, which is going to be a random number from 0 to 1, if a random float is I don't know, less than 0.5, so a 50% chance, we'll do something on the top or bottom, and else we're going to be doing something on the left and right. That would be a good way to think about it, because I find that for beginners, at least, because this video is aimed for beginners, the problem is not programming. The problem is thinking. No one tells the beginner that, hey, you have to think. Programming is a thinking activity. It's not something you can do mindlessly. It requires a lot of brain power. Trust me on that one. So we have a random float. So if it's a 50% chance, we're going to see if it's top or bottom. How do we decide if it's top or bottom? Well, we can make another 50% chance. So I'm just putting in pass because I want to divide the function up. So over here in this 50% chance, we'll do something on the top, but over here we'll do something on the bottom. And we can apply the same logic, and I'm just going to be copy pasting stuff. So copy paste that, Control C, Control V, and now we'll be doing this on the left side and the right side. So what does it mean to be on the top? Well, we can ask ourselves, what does it mean to be on the top, at the top of the screen? What does it mean to be up here? Well, it might mean that our global position .x, or .y rather, is going to be equal to 0, but our global position .x is going to be equal to a random range from 0 to screen size. And what is that? What does this mean? Well, it means that our global position .y is going to be up here, but our x position can be something random. So that's what this means. But what does it mean to be on the bottom then? Well, it means the exact same thing, except we're going to be putting our y position to the screen size .y, which is the bottom of the screen, because the positive side is, because the downwards direction is positive. That's why we can do this. That's why we can do global position .y equals screen size .y to spawn at the bottom. However, you can see that we're duplicating this line. We can see that this line is the exact same thing. And if I just get rid of this one, these two lines are the exact same thing, but they're in two different parts of our script. So this is called the scope of a function. So this is the scope of this else statement. This is the scope of this if block. But we want something to happen all the time if this top or bottom path is picked. So we can actually move this line up, and I did that by clicking Alt and the up arrow key. That's just really simple, a shortcut, really handy. Right now, we're basically saying that if we choose the top or bottom path, we're going to be setting our global position to a random x direction. So let's say the enemy spawns here. So it's going to say, okay, I'm choosing the top or bottom. So right now I want to set my random x position. So I'm either going to be on the top or the bottom, but I'm going to choose a random x position. And now I'm going to choose a random top or bottom. So that's what the second if statement is for. And now, since we're already doing this once, we don't need this second line. And I'm going to leave the comments there, I guess. And now we have a very simple way to make our enemies spawn at the top or bottom. But we don't have anything for the left and right. And just to make sure everything is working, you can see that they spawn from the top or bottom randomly, but we also want the left and right. Well, we can make something really similar to that, where we can just Control X this code or this line, put it over here. But instead of saying X, what is the equivalent for going left or right? Well, the equivalent is going to be, if this is our enemy, it's going to choose a random left or right. So right now, if it goes to this else block, because this expression didn't evaluate to true, so our enemy, if it chooses, because let's say this random f function, or this rand f function for this instance, or this example chooses like, it becomes 0.6, you can see that it will choose the bottom path. It will go to this else statement, and this else statement will say, okay, now choose, do you want to choose the left side or the right side? And let's say it chooses the left side. But notice, if it chooses the left side, it will have a random x position, which is incorrect. It should have a random y, and it should be up here, because we want to make sure that our random y position is chosen, kind of like up here. We want to make sure it's chosen regardless of what path it chooses down here. But what does it mean to be on the left or right? It means that your x position is either 0 or screen size.x. And to a beginner, you might be wondering, how are you thinking up of all of this? This is just pure thinking. This is what first principles thinking is called. It's thinking from the fundamental truth. Like draw it out on paint. Figure out where, like, how does stuff work, and you'll be able to make an amazing game from that. So over here, I'm just copy pasting these lines because I want to go on the right, but I want to make sure I change up my stuff. And now you can see I have enemies spawning from the left and the right, and they won't spawn. And you might be wondering, Nadlabs, why the hell do we have to do this complicated if block? Why couldn't I not have just done, let me just put this in a quick notepad. Why could I not have just done global position dot x is equal to a random range between 0 and screen size dot x, and I'm going to do the exact same thing for y. But why couldn't I not have done that? Well, the reason is because you'll get something like this. You'll get enemies spawning 1 centimeter away from you, and that's disgusting gameplay. So sometimes to get the most elegant result, you have to do a little bit extra stuff, a little bit extra coding. And you might be wondering now, why are the enemies moving toward me, even though at the beginning of the video, you showed me a different example? It's because if you think about it, in our game scene, we're setting the enemy direction. We don't want to. we want to tell the enemy direction to be different depending on the path it takes. So if the enemy spawns on the top, its direction should be equal to a vector 2 dot down. If it spawns at the bottom, it should be heading upwards. If it spawns on the left side, it should be heading rightwards. Not rigid, but right. And if it spawns on the right, it should be heading left. Now you might be wondering, whoa, what the hell is vector 2 dot left? Vector 2 dot left is basically a unit vector, which means, remember, it has a length of 1. A length of 1 just means it's really small. And it basically means that it's pointing in the left direction. Like it's pointing this way. Like there's nothing complicated here. Like sometimes as a beginner myself, I wish I could go back and tell myself to read things and take them word for word. Because sometimes the most complex thing is just word for word what it is on paper, and people get so scared about it, but you don't have to. And now you can see we get exactly what we had at the beginning. Okay, how long is this tutorial going on for? Okay, an hour. But I will show the example I was talking about earlier about stuff about the body. If you go, so this is a game I'm currently working on. You can see that when I hop over here into the player script, which by the way is getting pretty long, I will say so myself. You can see that I'm using stuff no different than what I showed you to make a bullet. Like, sure, this is a 3D game, and there are like sound effects and stuff, and there's music, and it took some time to load. Like, sure, I might be making a 3D game, but the fundamental principles is no different from what I showed you. I'm using groups. Yeah, I'm using groups. I was so scared because I was like, why is the bullet group player? But it's a player bullet, so that makes sense. So I'm using signals. I'm using everything I showed you to make a full 3D game. So what I showed you to make a simple game where you move around left and right to dodge some enemies, and this was my tutorial, like starter tutorial example. I'll also post this code just because. You can see that the stuff I'm using is no different than the stuff I was showcasing in this tutorial. Like, yeah, I'm using if statements. I'm using if statements right here. Like, there's no difference, or there's a very minute difference. I'm using variables. You're also using variables over there. Like, I'm just trying to show that the basics is so simple to pick up. But how do you pick up the basics? And I remember on Friday, I recorded a 30-minute video, which I discarded because most of it was useless. The way you learn, and basically the only message I said in that was make a lot of projects. And I mean a lot of projects. As you can see, if I scroll to the bottom, my first project was instancing, which is what I did a tutorial on. And this was about a year ago, I don't know. But basically you can see that instancing, I made a full project on instancing a scene. And you can see that I did some crazy stuff. Like I went Doom 3D Trial 1, like just make a bunch of projects. Like a bunch of random, weird, silly projects. And you'll eventually learn how to make 3D cool games like I did. And by the way, I've only been using Godot for a year. So I hopefully that puts stuff in perspective. And with that being said, have an amazing day. Not run, but return. Oh boy, this is going to be a long tutorial.